Hello. Hi, welcome back to my channel. Today is a report for our project management. My name is Rick Morita. Today, I would like to talk more about expected status belonging to ASIC Sentry module. Coming from milestone number 2 to milestone number 3. There's a lot of things that I want to tell you guys to do demos today. First of all, I want to do a recap a little bit about what we have in the milestone, in the previous milestone. In the previous milestone for the mining regulator in the commander role, we have RRC controls. If you remember, this one. Why is it important? It's gonna help you guys controlling the ASIC Miner remotely, turn on, turn off with a indicator, a light bulb. Now, in this, and it is for the recap. Right now, in the current version, we need to implement a feature, but in the ASIC Sentry, not in the commander. This guy, you see. Anyway, thanks to my friends, he had just designed this beautiful logo for me, and it support dark mode and light mode. I love it. Yes. Alright. So now come to our main demo. I need you to remember the order of the miner. 1, 2, 3. Okay. It had been sorting in ascending order. 1, 2, 3. Okay. So on the left hand side, the row here, it is the commander. Okay. And on the right hand side, it is the ASIC Sentry. Alright. So the demo today is all about how to remotely send the signal from the commander to the ASIC Sentry. Actually, it's not sending, it is a fetching process. So it means that for 5 seconds, every 5 seconds, an ASIC Sentry is gonna send a GET request to the commander that, hey, I have ASIC 1 with the API code here. I would like to know the expected status for my remote relay controller and in here. So as you can see, on the ASIC Sentry, the RRC control here, it's showing that it is turned on for the power and turn off for the light. However, if we modify or toggle button for power and light here, it's gonna set an update on the ASIC Sentry regarding our modification on the commander. So let's see. 5 seconds. Okay. So in here on the ASIC Sentry here, it's gonna have a new signal that turn off the light first, and in the future, we gonna have ESP32. This guy here. I don't know if you could see this guy here. ESP32, and it's gonna send a signal to the ASIC Sentry. This guy with our RRC serial number. For every single ESP32, when I do program it, I'm gonna assign an RRC serial number for every single module. It means that we need to have we need to do a mapping between the ASIC Miner and the RRC controller, because with this feature, we could control our power and indicator remotely. As you can see, the ASIC Miner is one module from manufacturer, from Bitmain, from iRiver, iPollo, any manufacturer. But our module here is gonna be an isolated one, and to control that remotely, we need to do a mapping between, hey, it is a ASIC and it is mapping to ESP32. This guy. I don't know if you could see this, but it's okay. Last but not least, in this version 3, we gonna have a mapping, and that mapping only appear if you edit it. So, for example, for this one, if you guys want to, if you guys have a new RRC remote relay controller, you need to turn it on and read serial number display on the LCD, like this one, display on the LCD here, and then typing that serial number display on that LCD. After that, and it is exactly the value for the remote relay controller. For example, x something like this one, okay. And last but not least, what's important, when you create a new ASIC miner, there will be no field for you to input the RRC. I believe that the RRC is gonna bring the most value to the table, and at the moment it's a closed source. Yeah, it's not open source, but let's see if I could make things happen first. Supposedly it's gonna be very simple, just send API a yes or no and then turn off. Yeah, for controlling that kind of ESP32 is not simple, at least for me. Today I have bought a new course to learn Rust. This one. Yep. Oh, you see, I have purchased it today, May 13. All right. I want, before we finish this demo, I want to go back a little bit about our milestone. Where is this one? So our milestone 3 had been achieved today, and today what we have implement an API to get expected status from the commander, first thing, and we also implement an API return expected status for the RRC, the ESP32 that I showed you today. Yep, this is LCD. And the final one, it is implement an UI for mapping the ASIC Miner and RRC. Yeah, but I mean the milestone is simple, but to implement it, it's not simple. Before, I think it's gonna be like easy, and we don't have to do real-time update for the for the ASIC Sentry, but for now it's more important than I think. Let's do it again. Yeah, this in the for the power value and light value, they are on update in real time. Hey, and remember that's one, that it always for the power, it always asks for permission, like a confirmation before it toggle the up button. You see here, let's turn it on. Right. All right, so that's all for today, I guess. All for the RRC and feature. Yeah, update a little bit. And in addition, for the testing right now is like 100% for the ASIC Sentry, and I'm very happy to show you this one. ASIC Sentry. And for testing, there are some, it's not unit test, it is integration test. It means that it is integration test, so it means that we don't we need a third party, like a third party server like Commander, for testing sample request and get outcome for testing. So remember, if you clone the source code yourself, remember that when you run test, you need to set that I don't want to run unit test. We have a tag named integration test, because if you run the test, you need to run Commander with a prefix or setting a value in the database first. Test. Ooh, what happened? Yeah, I think I run migration. No, it's not. Yeah, it is. What happened if you make a mistake? What I want to say is integration. Damn, man. Right. So for include here, it's important because you gonna need to run Commander. Yeah, it's gonna send some data to the Commander for testing, and it need setting data in the Commander. Yeah, you see, zero failure. There's some warning, but never mind. I am lazy to modify this a little bit, but I gonna resolve it in the future. So let's see. Remember, next step include integration test. Alright. And this is a whole story for us right now today. That's all. That's all. I wonder. Yeah, but anyway, it's a good fun, right? So I think it is a little bit more fun if I could share to you about our electronic device block model, about the RRC, the remote relay controller. How should it look like? Let me explain a little bit, share you a little bit about what should it look like. So we gonna have PSU, I mean the power supply unit at 5 volt. So it's gonna provide power for our ESP32. This guy. And it's LCD, of course. On the other hand, we have the power supply to 20 volt. We're gonna supply power for our indicator, a light bulb, and a relay PDA. It is a solid relay state, SSR. Yep, and then on our ASIC miner. The yellow, so for the yellow block, it refers to the power consumption, the main power consumption. Yeah, we're using 220 volt. On the other hand, ASIC Sentry here, it is just our ASIC Sentry, this one. I mean, this one. This is ASIC Sentry. Yeah, and the ESP32. So on this block diagram, we're gonna have the ESP32 connecting to Wi-Fi first. We need to do some hard code. There is no UI for this one. And for the ESP32, it set a message to ASIC Sentry that's, hey, my serial number is something, and I want to get expected status of related ASIC Sentry. I mean of the related ASIC miner. Okay, done. After that, it's gonna have a response from ASIC Sentry that hey, we expect that the ASIC power consumption should be turned off and the light indicator should be turned off. Alright, after that, it's gonna control our relay. So what the relay look like? It's gonna be like this one. I love to open it. This is how it looks like. This is the relay. This one. So that's relay. So the relay here is gonna be dual like X2 model. So it means that a single ESP32 could control this board, and this board can control relay for two power consumption, two sub module, and in here it is one light bulb and an indicator, and the other one it is our relay for higher power consumption. I think it is risky to control ESP32 with PDI 40 arm. I don't like it. Yep, and as you could see, we after the ESP32 here, it received data from ASIC Sentry. It's gonna send a signal to turn on or off signal to the relay, and after that the relay here it turn on the light, turn off the light, and the relay here it gonna send signal to another relay, which is higher relay, to control our ASIC miner, and that's the whole story. Exactly, it is the whole story for everything, right? On the other hand, when I design this system, in the future we're gonna have another module, a small one here. It is a sensor. It is the power, I mean like current sensor. Excuse me. Like this one here. A current sensor gonna be staying here, and another current sensor is gonna be in here. Remember that the PSU 5 voltage, it is not coming out from nowhere. It means that to turn on, to do power supply for the 5 voltage power supply, we need to 20 voltage to do power supply for that module. And yeah, we're gonna have another current sensor at this point also. So by using this way, we can easily determine the power consumption of ASIC miner of the of our module like ESP32, but I don't think it brings the most value. Probably we can just put the sensor here instead of there, right before the ASIC miner. We can just put the current sensor here, and after that thing gonna be fun, like this one, the power here. And as you can see, it is out, and as you can see, we can easily design the system at the very minimal version. Because of the limited time that I have, I will not provide the UI for ESP32 to like hey, this is my serial, like this, like choosing Wi-Fi remotely. I see some logger, I see some logger like solar panel logger, they when they provide that device, they set up a Wi-Fi host for that system, and then when I connect to that server, I gonna update, I gonna scan the Wi-Fi that we have, and then assign that Wi-Fi network SSID to the ESP32. For this milestone, for this release, no, we don't have that one, because it brings less value for me at the moment. We really want to implement on-off ASIC miner, and I have a wait for this one. I really don't want to waste any time. And yeah, that is learning. In addition, learning Rust, it is a little bit difficult for me. It's a little bit difficult because it's new for me. So I buy course for this one. Anyway, I think we have reached to our end of the demo today or projects reporting today. It's not difficult, but it takes time too much. Most of the time I spend right now for the project today, actually, it's not about um, designing the IoT device, but it is about how to write unit tests. As a consequence, I'm quite happy that we have here 55 tests, zero failure for unit testing. It looks awesome. All right, I think we have come to the end of this demo today. See ya.